Q6672. Deviation error of the magnetic compass is caused by A. Northerly turning error. B. Certain metals and electrical systems within the aircraft. C. The difference in location of true north and magnetic north. The correct answer is B. Deviation error of the magnetic compass is primarily caused by certain metals and electrical systems within the aircraft. When an aircraft is equipped with metallic components or electrical systems, they can create magnetic fields that interfere with the proper functioning of the magnetic compass. This interference leads to deviation errors, which are deviations from the correct magnetic heading. Metals present in the aircraft can become magnetized or create their own magnetic fields, which can influence the magnetic compass. This is particularly true for ferromagnetic materials that have a strong magnetic response, such as iron, steel, or permanent magnets. These materials can distort the Earth's magnetic field, affecting the accuracy of the compass reading. Additionally, electrical systems in the aircraft can generate electromagnetic fields that can disrupt the magnetic compass. The flow of electrical currents and the presence of wires carrying electric power can create magnetic fields that interfere with the compass. This interference can cause the compass to provide inaccurate readings, leading to deviation errors. Q6675. Which statement is true about magnetic deviation of a compass? A. Deviation is the same for all aircraft in the same locality. B. Deviation varies for different headings of the same aircraft. C. Deviation is different in a given aircraft in different localities. The correct answer is B. Magnetic deviation refers to the angular difference between magnetic north and true north, as indicated by a compass. It occurs due to the presence of magnetic fields generated by various factors, such as the Earth's magnetic field and magnetic materials within an aircraft. The deviation is not constant for all headings of the same aircraft because the magnetic fields influencing the compass can vary depending on the orientation of the aircraft relative to these fields. This means that the magnetic deviation will change as the aircraft changes its heading. Several factors can contribute to the variation in magnetic deviation for different headings. 1. Aircraft structure. The structure of an aircraft, including the presence of ferrous metals or electrical systems, can create magnetic fields that interfere with the compass. Different parts of the aircraft may produce varying levels of magnetic influence, resulting in different deviations for different headings. 2. Magnetic field variations. The Earth's magnetic field is not uniform across all locations and can vary in intensity and direction. These variations can affect the compass readings differently depending on the heading of the aircraft relative to the magnetic field lines. Therefore, the magnetic deviation will differ for different headings. 3. External influences. Other external magnetic fields, such as those caused by power lines, radio equipment, or nearby aircraft, can also influence the compass readings. The strength and orientation of these external fields may differ as the aircraft changes its heading, leading to variations in magnetic deviation. In conclusion, the magnetic deviation of a compass varies for different headings of the same aircraft due to the complex interplay of factors such as the aircraft structure, magnetic field variations, and external influences. It is important for pilots to account for these variations when using a compass for navigation purposes. Q6670. In the Northern Hemisphere, a magnetic compass will normally indicate a turn toward the north if A. A left turn is entered from a heading. B. An aircraft is decelerated while on an east or west heading. C. An aircraft is accelerated while on an east or west heading. The correct answer is C. In the Northern Hemisphere, a magnetic compass will normally indicate a turn toward the north if an aircraft is accelerated while on an east or west heading. The behavior of a magnetic compass is influenced by the Earth's magnetic field and the forces acting on the compass needle. In the Northern Hemisphere, the magnetic field lines are oriented in a general north to south direction. The compass needle aligns itself with these magnetic field lines, indicating the magnetic north. When an aircraft is on an east or west heading, parallel to the magnetic field lines, Any change in speed or acceleration can cause the compass needle to deflect. 6671. In the Northern Hemisphere, if an aircraft is accelerated or decelerated, the magnetic compass will normally indicate A. A turn momentarily, with changes in airspeed on any heading. B. A turn toward the south while accelerating on a west heading. C. Correctly when on a north or south heading while either accelerating or decelerating. The correct answer is C. The magnetic compass will indicate correctly when the aircraft is on a north or south heading while either accelerating or decelerating. This is because the magnetic compass is primarily affected by changes in the Earth's magnetic field, which is aligned along the north-south axis. When an aircraft is flying on a north or south heading, the magnetic compass needle aligns itself with the Earth's magnetic field and points to magnetic north. This allows pilots to accurately determine their direction of flight. Accelerating or decelerating the aircraft does not significantly affect the accuracy of the magnetic compass while on a north or south heading. The compass needle will continue to point to magnetic north, regardless of changes in airspeed. However, it's worth noting that the magnetic compass is subject to errors and disturbances caused by factors such as magnetic fields within the aircraft, electrical systems, and nearby magnetic objects. These errors are typically accounted for and corrected through the use of other navigational instruments, such as gyroscopic compasses and electronic heading systems, which provide more accurate heading information. Nonetheless, the magnetic compass remains an important backup and reference instrument for pilots. 6673. In the Northern Hemisphere, which would be correct about starting the rollout from a turn using a magnetic compass. Start the rollout. A. After the compass indication passes south by a number of degrees approximately equal to the latitude minus the normal rollout lead. B. Before the indication reaches south by a number of degrees approximately equal to the latitude over which the turn is made plus the pilot's normal lead. C. After the compass indication passes south by a number of degrees approximately equal to the magnetic variation of the area over which the turn is made plus the pilot's normal lead. The correct answer is A. When an aircraft is turning in the Northern Hemisphere, the magnetic compass will indicate a turn toward the north. This is because the compass needle is influenced by the Earth's magnetic field, which is oriented along the north-south axis. During a turn, the compass needle lags behind the actual heading of the aircraft due to the inertia of the compass card. This phenomenon is known as lead or turning errors. The magnitude of the lead depends on various factors, such as the rate of turn and the latitude. To execute a coordinated turn and roll out on the desired heading, pilots use a technique called rolling out with a lead. This means starting the rollout from the turn before reaching the desired heading in order to compensate for the compass lead. In the Northern Hemisphere, the correct technique is to start the rollout after the compass indication passes south. The number of degrees to wait after passing south is approximately equal to the latitude minus the normal rollout lead. The reason for subtracting the normal rollout lead from the latitude is to account for the lead and ensure that the aircraft rolls out on the desired heading. By using this technique, pilots can minimize errors caused by the compass lead and execute more accurate turns and rollouts.